Hi, my name is Jake Abbott. This is the Zoom recording to introduce you to the robotics group, the robotics graduate program at the University of Utah. I'm the head. We take turns who is the head of the robotics division, and I'm the head of the robotics division now, which is why I'm speaking to you. So first thing you should know is that at the University of Utah, we run the robotics graduate program across departments. So traditionally, that's been the Department of Mechanical Engineering and the School of Computing, but recently the Department of Electrical Engineering got folded in. So grad students can enter from all three of those departments, but then basically once you're in the program, the idea is that you're basically a robotics student and you can take classes with all the other robotics students. And we do that through a robotics track. And I'll come back to that at the end and talk about that in more detail. And you can also stop listening to me then if you want, or you can keep listening for the robotics track info. But the most important thing to know right now is that if you are part of the robotics track, then professors in any department can be your advisor. So although you are applying to the Department of Mechanical Engineering, if you find that the research of a School of Computing faculty or an electrical engineering faculty is right for you, then they can be your advisor. That's because of the way we run robotics as an interdisciplinary group. So I think what I want to do right now is I just want to introduce you to the professors and what they do in robotics at Utah. Okay, so I'll go through mechanical engineering first, and then School of Computing, then electrical and computer engineering. And I'll just talk about us in alphabetical order, okay? And I'm just gonna give you a really brief introduction to what we work on. So my name is Jake Abbott again. I work on medical robotics and magnetic manipulation. Those are my two main topics. And then I also work on haptics, which is this idea of providing force feedback to a human hand as you're doing some sort of robotic task, either teleoperating a robot to a remote location or interacting with virtual environments. And then really most of my projects are somehow at the intersection of these three things. So a bunch of my work is on using magnetic fields for medical robotics or using haptics and teleoperation for medical robotics. Then we have Cam Liang. Cam Liang in his group, he sort of is a jack of all trades a little bit, like a lot of us are, but he has three main thrusts, I would say. One thrust is flying robots, specifically quad rotors, and he's very interested in sort of mobile sensor networks. So robots that can fly around and find skiers that are buried under an avalanche, or can detect where a gas leak is coming from. His other thrust is soft robotics, and he works on these different kinds of electroactive polymers. So they're these soft kind of silicone rubber looking things, but then you can apply electricity to them and they'll move, and you can make various things that swim and crawl that way. And then the other thing he works on is high-speed nano positioning. So basically, if you want to look at single molecules under an atomic force microscope, can you do that really fast and really accurately to the point where you can do this at like video rates? So those are Cam's three thrusts. Then we have Tommaso Lindsey. Tommaso Lindsey's expertise is on robotics for the legs of humans. So that means prosthetic limbs, prosthetic legs, prosthetic ankles, prosthetic knees, prosthetic hips, and then also lower limb exoskeletons for rehabilitation purpose. He's very much a mechanical engineer. So his skill set is on design, mechatronics, control. And then also he understands the real human aspect of this and working with patients. Why I say he's a real mechanical engineer is because we have another person who's doing prosthetics from a different point of view that I'll get to in a minute. So then we have Mark Miner. I'm going maybe a little out of alphabetical order. Everyone has M's now. Mark Miner. Traditionally, Mark has done a lot of work on mobile robotics, like autonomous vehicles, different kinds of robots that crawl and fly. He does still do some flying robotics work right now, but I think lately it seems like the bulk of his work is in different kinds of soft robots. So for example, he has a project that involves a soft robotic sole of a shoe that's full of these bladders, and you can basically add and subtract air from these bladders so rapidly that when the person takes a step, they perceive a different ground. Like you can perceive that you're walking on rocks, or you can perceive that you're on the edge of a sidewalk, or that there's a slope to the ground. And so these are basically like special shoes that you can put people inside a virtual environment, and they can actually feel the ground is feeling different, even though they're just like walking on a treadmill. He also has been working on an instrumented kind of football helmet, in which you can basically detect if a collision is about to happen, and you can protect the person's head before that collision happens. So he's really gotten into this space of different kinds of soft mechatronic devices that are meant to directly interface with human beings. Then we have Steve Mascaro. Steve Mascaro also has a few different projects that he works on. A lot of his work these days is on designing robot hands that are could be an autonomous robot's hands, or it could be used for prosthetic hands. But the main idea is to reconstruct an artificial hand that is very, very similar to the way an actual human hand works, with the tendon structure and the muscle structure and everything. Traditionally, he's worked on a lot of shape memory alloy devices. So these are devices where you basically have a wire that that has certain elastic properties, and when you apply electricity to it, it returns to some previously remembered shape. And using these, you can make artificial muscle type things. And then Steve also does a lot of work with imaging fingernails and looking at how much can you figure out about what a human hand is doing as they grab onto an object by just staring at their fingernails. If you look down and press your fingernail on something, you'll see actually the blood pools differently, and the ratio of sort of whites and pinks and things shift around. And that visually has the information to figure out how hard you're holding on to something. So you could basically make force sensorless ways to measure how people are gripping onto objects and things. Then we have Sandy Meek, Sanford Meek. He goes by Sandy Meek. Historically, he has done a lot of research on prosthetic hands. So these would be prosthetic hands that are interfacing either through EMG or through peripheral nerves to your stump. But lately, most of Sandy's work has been on quadruped robots. So basically 4-legged robots that sort of run and trot and walk like little dogs or little horses. Okay, I think that's everyone in mechanical engineering, but because you're interested in robotics, I should tell you about what everyone's doing in robotics. So then in School of Computing, we have John Hollerbeck. John Hollerbeck almost exclusively works on this big custom virtual environment, that haptic device that he has created over the years called the Treadport. It's a completely immersive device. You're on a treadmill, a robotic tether can push and pull on your back, and one can pull on you to the ceiling, and then you're surrounded with screens, and those screens are integrated with wind and smell displays. And so you can create completely immersive virtual environments that a person can walk around in, and it feels physically realistic because the tether on your back replicates the effective inertia of your body. So starting and stopping your body from walking isn't trivially easy. Then we have Tucker Hermans. Tucker Hermans, his expertise, he works on a bunch of different projects because he has a kind of a valuable skill set that a lot of people have liked. So he's a collaborator on many projects, including one with me. But his main area of expertise in his own group is autonomous robotic manipulation. He wants to make robot arms and hands do manipulation like a human can do. And if you think about the ways that humans manipulate the world, it looks very different from the way a robot in an industrial setting manipulates the world. We know how to grab things and manipulate them inside of our hand and adjust them. We know how to use all different parts of our fingers and our palms, and we can manipulate like piles of objects. You know, if I ask you to clean off your desk, you're not necessarily going to go and pinch every single device, every single object on your desk one at a time. You can do things like scooping things into a bowl. So he wants to make robots get to that level of ability. Then we have our newest hire in that department, Alan Koontz. Alan Koontz is a motion planning expert, and he's also a medical robotics expert. And most of his research is going to be at the intersection of those two things. So he's trying to make medical robotics, mostly surgical robotics, but also I think some home care and rehabilitation application. But he really wants to apply motion planning techniques, which means, can I figure out how to get from sort of point A to point B, where point can be a very complex state that you're thinking about. How do I get from point A to point B efficiently without colliding with things? That's what motion planning means in the context of robotics. And then we have our two new hires, brand new hires in electrical engineering. Jacob George is in his first semester right now. He works on prosthetic hands, but he's coming at it rather than from a mechanical engineering point of view like Tommaso. He's coming at it from a bioengineering and electrical engineering point of view. So he's very interested in the actual problem of interfacing with the human nervous system through the nerves, through the brain. And so I'm pretty sure he's going to be looking for students to build up his group. He's just starting this semester. And then we also have another hire that's actually not even here yet. He's starting in the fall though. And he's also looking for students to build up his group. His name is Daniel Drew. He's currently a postdoc at Stanford. And he'll be starting. He's interested in making, at the interface of MEMS, which is micro electromechanical systems. So these are the kind of things you use, like circuit chip designing and fabrication techniques to make little mechatronic devices. And he's interested in building small robots using those techniques. And his prior work is he's created this very interesting little tiny flying robot that has no moving parts. It doesn't have any propellers at all. It just uses what's called ion engines. And so that's a very exciting area. And so that is the overview of the research and the professors in the robotics program. If you want to stop watching now, that's totally fine. And now I'm just going to take just a brief minute to introduce you to the robotics track. You can always come back to this. So let me share my screen and I'm going to show you what the current draft of the robotics track looks like. When I say the current draft, I mean the current version. So this is the robotics track, and what the robotics track is, so what a track is it's a way for you can basically choose to either complete the Department of Mechanical Engineering's graduation requirements, or you can meet the robotics track graduation requirements, and those are completely detailed on this sheet. You don't have to meet both. You meet one or the other. Either way, your degree will say you have a degree in mechanical engineering, whichever you do, but it lets you not have to meet two sets of graduation requirements. And basically how the robotics track works is we have these 5 categories, and you see this top row called core courses. Every student must take one course from each of these, which effectively means every student takes Intro to Robotics, Intro to Robot Control, one of Motion Planning or Artificial Intelligence, and then one of Image Processing or Computer Vision. Now, the thing is, image processing is a prereq for computer vision. So for most people, that means they're going to be taking image processing if they only take one. Then the degree requirements, if you're getting a PhD, a thesis master's degree, or a non-thesis master's, are different, and they're laid out here. But the basic idea is you have to pick at least 2 of these categories and take elective courses from those. And you can see the courses are mechanics. That's about describing how things are sort of moved through space. Control systems. Cognition, that's essentially the brain of a robot. Perception, that's essentially the eyes of a robot. Human-robot interaction, and then robot design. And we're constantly adding new classes, and I'm sure if you come into this program, because of all the new people we've hired in the last year, there will be new courses that they'll want to offer that will be added to these as well. Also, because you're mechanical engineers, let me just say, for most mechanical engineers, we find that their programming skills maybe isn't as strong as they would want them to be to make all of their courses easy. So we've developed this course that we call Programming for Engineers. And that's a graduate level programming course that was really designed for first semester mechanical engineering robotics track students. We offer it every fall. And if you're someone who wants to do robotics, but you know your programming maybe isn't as strong as it could be, you should definitely take this class in your first semester in the program. And that will help you in some of the other classes that follow. For example, the motion planning class, the image processing class, computer vision, those will all be easier because you took programming for engineers. Okay, I think I'm going to end there. If you have any questions, feel free to reach out to me or anyone else.